Humanity has always looked up at the moon, a constant companion in our night sky, a celestial mirror reflecting our curiosity and our ambition. For millennia, it was unreachable. For centuries, unimaginable. And then, in 1969, two men walked on its surface, kicking up dust older than life on Earth. Since then, the moon has receded from the spotlight, quietly orbiting above while we turned our attention elsewhere. But now, it's returning to the center of the human story, in plans and proposals, in launch pads and contracts, in dreams rekindled. We talk of lunar bases, resource extraction, and long-term settlement. But beneath the hope and excitement lies a harder truth, one that doesn't make headlines as easily. The moon is not a second Earth. It is a world that challenges every assumption we have about survival. This is not about romanticizing the moon. This is about facing it as it is. This is a reality check. At a distance, the moon is beautiful, a pale marble drifting through blackness, familiar and calm. But the closer we get, the more alien it becomes. There is no air, no weather, no sound, nothing soft or soothing. The surface is a harsh, frozen vacuum, sculpted not by winds or rivers, but by billions of years of impacts. Craters within craters, rocks untouched by erosion, dust that hasn't shifted in eons. The temperature extremes are staggering. During the lunar day, surface temperatures can exceed 120 degrees Celsius, hot enough to boil water. When night falls, the thermometer plunges below minus 170 degrees. These days and nights each last about 14 Earth days, meaning any structure must endure weeks of unrelenting heat followed by weeks of deadly cold. And then there's radiation. On Earth, we are shielded by a magnetic field and thick atmosphere. On the moon, that protection vanishes. Cosmic rays and solar particles rain down without resistance. A single burst from the sun, a coronal mass ejection, could expose astronauts to lethal doses unless they're protected underground or behind substantial shielding. Living on the moon means living in a constant state of defense from light, from cold, from radiation. It means turning a place that was never meant for life into a place that might barely support it. Even if we survive the environment, we have to construct shelter in one of the most unforgiving places imaginable. Every kilogram sent to the moon costs tens of thousands of dollars. Launching entire buildings is impractical. We'll need to build with what's already there. Lunar regolith, that gray, dusty soil, is plentiful, but it's also sharp as ground glass and clings to everything it touches. We may one day melt it into bricks using solar heat, or combine it with binding agents to 3D print habitats. But no one has ever done this outside of lab conditions. We don't yet know how regolith behaves under pressure, radiation, or temperature swings in real lunar gravity. Machines will do the early work: robotic excavators, printers, cranes, all controlled from Earth or autonomously. These machines will need to operate in darkness, in cold, with limited maintenance. Failure will be frequent. And replacements? They'll be 400,000 kilometers away. Power is another hurdle. The moon has no power grid, no fossil fuels, and no easy battery solutions. Solar energy is abundant during the day, but the 2-week-long lunar night requires long-term energy storage or alternative sources. Nuclear reactors, perhaps, but that comes with its own risks. A lunar outpost won't rise quickly. It will come piece by piece, like assembling an outpost in the Arctic, except colder, darker, and much farther from help. Without water, there is no moon base. Water is more than hydration. It is air. It is fuel. It is survival. On Earth, it falls from the sky. On the moon, It must be mined, processed, and protected like treasure. For decades, we thought the moon was bone dry. But in the early 2000s, orbiters began detecting signs of water ice in deep polar craters, places where sunlight never reaches. These are some of the coldest locations in the solar system, colder even than Pluto. In these eternal shadows, frozen water lies trapped in soil grains, possibly billions of tons of it. If we can reach it, we can melt it, drink it, split it into hydrogen and oxygen, turn it into rocket fuel. But getting to it is anything but simple. The terrain in these craters is jagged and treacherous. The temperatures are so low that most electronics fail instantly. Solar power is ineffective here. Mining operations would require nuclear energy, advanced robotics, and years of testing. Still, if we want to stay on the moon, not just visit, we will need to go where the ice is. Water is the currency of life. And on the moon, it may be the most valuable resource of all. Now imagine living there. Inside a small, pressurized module, walls half a meter thick, lined with radiation shielding, regolith, or water tanks. Windows are rare, if they exist at all. Outside is death. Inside is life, carefully measured. Every breath of air is recycled. Every drop of water is reclaimed. You sleep under artificial lights. You eat freeze-dried food. You exercise for hours a day to prevent your bones from dissolving in low gravity. The moon's 1/6 gravity may feel fun at first, bounding across the surface, floating in slow arcs, but it takes a toll. Our bodies evolved for Earth. Our bones, muscles, and circulatory systems depend on gravity. Without it, we weaken. Our balance shifts. Our immune systems act strangely. No one knows the long-term effects of lunar gravity. And then there's the mind. Lunar days and nights last 14 Earth days. Circadian rhythms drift. Time begins to blur. You can't go outside without a suit. You can't take a walk in the park. You can't hear birds, smell flowers, feel rain. You are isolated, confined, dependent on machines. Living on the moon means living in a world without color, without weather, without life. And yet, some will choose it. For science, for exploration, for the future. But it won't be easy. It won't be normal. It will be survival every moment of every day. So why endure all this? Why try to live on the moon at all? Because the moon is more than a rock. It's a proving ground, a platform, a gateway. If we can survive on the moon, we can survive elsewhere. Mars, Europa, Titan. The moon is the closest place where we can practice living off Earth in real conditions with real risk. It's also strategically important. The moon's lower gravity means launching spacecraft from its surface requires far less energy than from Earth. A lunar base could one day become a fueling station, a stepping stone to the rest of the solar system. And then there's the intangible reason, the human reason, to explore, to endure, to expand, to take our first true steps into the cosmos. The moon is a test of technology, of politics, of our collective will. Passing that test may define the next century of human history. So where are we now? NASA's Artemis program plans to return astronauts to the lunar surface within this decade. The European Space Agency, China, India, and private companies like SpaceX and Blue Origin are all preparing their own lunar strategies. But landing is just the beginning. Lunar living will require hundreds of cargo missions, years of robotic construction, and unprecedented international cooperation. It won't be a single moment. It will be a process, a gradual unfolding of presence. First will come temporary bases, research modules, rovers scouting for ice. Then, if we succeed, semi-permanent settlements, power systems, greenhouses, communications networks. Eventually, maybe decades from now, a village, a lab, a home. But the timeline is long, and the path is hard. We are just now returning, and staying will be the challenge of a generation.